Hello guys, you are welcome to I Plus Academy. My name is Olanipekun Oluwagbenga and I will be taking you through revision on chemistry practical, especially for the SS3 students that will be taking their Waec very soon. Please, if you are new on this channel, please subscribe to our YouTube channel and press the bell for notifications of our previous videos and the ones we are going to be doing in the nearest future, so that you will not miss from any of our videos. Thank you. So now let's look at the question. Now, in chemistry practical, we have three sections. We have the titration sections, then we have the quantitative analysis, and then we have general questions in which any question can come out from there. And then from the titration practical is very easy. Once we can identify and know the formulas we are going to be using. Look at this question now. A is a solution of triazonitrate 5 acid. Now look at that. A of unknown concentration, that is for A. Now B is a standard solution, that means the concentration is known, of sodium hydroxide containing 4 gram per dm cube. That is a concentration of B. That's why we call it a standard solution. So a standard solution is a solution whose concentration is known. Now, 25 centimeter cube portion of solution B requires an average of 4 centimeter cube. Now, in titration, we are required to calculate the average volume of acid used, and they are usually represented in a tabular form. If you have been following our videos, you will notice that we have done something like that. I've taught you how to put the values you got from your bullet reading and from your bullet reading during the practical down on your table for complete neutralization. But in this case, I will not be doing the table, but this is the value that we always put in the table, that we always get from the table. Good. The first question says, state with reasons a suitable indicator for the titration. And we have different reasons why we use different indicators. Now, you have to first identify whether an acid is strong or weak acid, and if the base is also strong or weak. Now, in this case, triazonitrate 5 acid is a strong acid, and sodium hydroxide also is a strong base. So in this case, any indicator can be used. So the first answer we are going to be having here is for question 1 now. The question says, what is the choice of what indicator? So the correct answer is any indicator. Any indicator can be used. Any indicator, which could be methyl orange. But if you have to answer this question in the exam, you have to just write methyl orange. Just write one of them. But because I'm teaching you now, you can write methyl orange or phenolphthalein. So any one of them can be used, because what? We are dealing with strong acid, strong base, right? Very good. So phenolphthalein, you have to get your spelling right. Phenolphthalein can be used. Now, anytime you have, let me just teach you further about that. So anytime you have weak acid, please listen to this. Weak acid versus strong base. In this case, you are meant to use phenolphthalein, please. You are meant to use phenolphthalein. So this is phenolphthalein. Phenolphthalein. Now, if you are dealing with strong acid, versus weak base, please note this: strong acid versus weak base. In this case, you are meant to use methyl orange. Is that okay? Methyl orange. Very good. You are meant to use methyl orange. So I think we have answered the question for question 1. Now let's see what we have for question 2. Question 2 says, write a balanced equation for the reaction. And the reaction is between HNO3 and sodium hydroxide. So we have to write the balanced equation for that. So let's erase this so that we can move on from there. So we have to write a balanced equation for that, right? Okay, good. So let's see what we have there. Now, HNO3 is the acid, while NaOH is what? Is the base. Good. So let's continue from there. So that means we have a balanced equation will be written this way. HNO3, the acid, when it reacts with what? Sodium hydroxide, is reacting with this, it will surely give us, look at that now, sodium and this will go together, and that gives us sodium triazonitrate 5. Good. Plus water, and we call this what? Neutralization. So the remaining, we are left with H and OH, and that gives us water. So that is our question B, and we have answered question B. Now to the real question. Now let's look at what we are given from the question again. You will notice that we are given the concentration of sodium hydroxide, that is the standard solution, 4 grams per dm cube. 4 grams per dm cube, that is mass concentration. And we are also given the what? The solution B, that is the volume that we usually get from the pipette. And we are given what? The volume of acid used. So let's move on from there. So see what we are given here. Let's bring it out. We have volume of B given. We usually got this from what? From the pipette, 25 centimeter cube. And we are given the volume of A that usually calculate from titration. And that is from this question that we have 24 centimeter cube. Very good. And then we are also being given the mass concentration. Is that okay? To be what? 4 grams per dm cube. So that is the mass concentration in grams per dm cube. Now the question says, find the mass concentration of B in moles per dm cube. That's the first question, the molar concentration. The molar concentration. So this is a mass conc of B. Is that okay? Now there's a formula we are going to use here that says, please, you have to know this formula. Mass concentration now. Mass concentration of B equals molar concentration times molar mass, right? Times molar mass. So in this case, we know the mass concentration. We are now looking for the molar concentration. So let's put the values that we have there. What is our mass concentration that we are given? We are given 4 as the mass conc of B, and we are looking for the molar conc. So we have the molar conc we are looking for. Then times the molar mass. I can calculate the molar mass of sodium hydroxide. Look at the formula we have, NaOH. And we have been given the value of sodium to be 23 from the question. Oxygen is 16. and the hydrogen is 1 there. So when you do this very well, we're not going to be having 4 equals to the molar concentration, molar conc, times the molar mass will now give us 40 gram per mole, such that our molar conc will now be equals to 4 over 40 when you divide both sides by 40. And the answer for molar conc of B is now 0.1 mole per dm cube. So we have answered the first question for part C. So molar conc for solution B is that. Now part 2 says C2. It said find the molar conc for what? For solution A. Now to calculate the molar conc for solution A, we need to use the formula Ca Va, because we have known we know Va. We just calculated Cb now and we know Vb. So we can now have Na over Nb. So let's bring out the values of what we have known. Ca is the molar conc of what? Of the acid is unknown. Is that okay? Then Va has been known as well to be what? To be the values we are given that we are always getting from the titration was given to be 24 decimeter cube. And also we know Vb was given as centimeter cube, right? Centimeter cube. Then Vb, this one is a constant from a titration, 25 centimeter cube. And we just calculated our Cb now. That is molar conc of base, 0.1 mole per dm cube, right? So let's put the values into the equation and let's see what we're going to be getting. So we're going to be having this. We are looking for Ca times Va, we have 24. Everything over 0.1 times 25. So that gives us 1 over 1. Now see where we got our 1 over 1 from the Na over Nb. From your equation, Na is the coefficient of the acid, while Nb is the coefficient of the base. Please note that. And that is 1 over 1, right? So we're going to be having that here, 1 over 1. So we can move on from there. So that becomes 24 Ca equals, if you cross multiply, 0.1 times 25. So divide both sides by 24. Excuse me. 24, such that we have Ca equals 0.104 moles per dm cube. So that is the molar conc of the acid in moles per dm cube. Now question 2, which is the final one, question 3 rather, of C, says calculate the mass conc of A. So remember the formula I gave you. Mass conc equals to what? Molar conc times what? Molar mass. Then having known the molar conc already, so we can now say that our mass concentration will now be equals to what now? So our mass concentration that we are looking for will now be molar concentration that we calculated just now to be what? 0.104, very good, times the molar mass of HNO3. HNO3. How can we calculate the molar mass again? Remember what I taught you about that. H is 1, you are given that. N is what? 14. And oxygen is 16. So we have 16 times 3, right? So that our mass conc in grams per dm cube will now be equals to 0. This, then times everything here. If you do it very well, we're getting 63. So if you multiply 0.104 times 63, so you're going to be getting 6.55 grams per dm cube. So we have finally done justice to the question. So we calculate the mass conc of the acid. Let's look at it again. Concentration in grams per dm cube of HNO3. That is our third question, which we have just calculated. And that is now what going to be. So we now write, therefore, the concentration of that will now give us the value of acid will now give us 6.533 grams per dm cube. Thank you for listening. See you in another video we are going to be doing for titration.